Good morning everyone. Today we are going to discuss our second chapter. The name of our chapter is Equations of Motion. Okay, here the chapter deals with mainly two things. The first one is about graph and the second one is about three equations of motion. Okay, I think in earlier classes you have studied about how to draw a graph, isn't it? When we say the body is said to be in motion, a body is said to be in motion if it changes its position. With respect to what? With respect to its surroundings with the passage of time. Okay, once more I will say a body is said to be in motion if it changes its position with respect to its surroundings with the passage of time. Okay, so in earlier classes you have studied about what is distance, displacement, speed, temperature, time, etc. We can call these as quantities. Okay, so there are two types of quantities. Do you know which are they? I told you that there are two types of quantities. Do you know which are they? The first one is scalar and the second one is vector. Okay, scalar. In scalar quantity, it have only magnitude and no direction. Only magnitude. And no direction. Okay, that means it have only a particular type of value we can see it. Okay, can you give examples for scalar quantities? Yes. Mass, time, then temperature. Okay, then what do you mean by vector quantity? Yes, vector quantities have both magnitude as well as direction. Vector quantity. Vector quantity have both magnitude as well as direction. Okay, vector quantity have both magnitude and direction. Okay, if we say a bus is said to be in motion and its velocity is 40 km per second. So, the bus is moving according to a particular direction as well as a magnitude. Okay, once more I will say if a bus is said to be in motion and its velocity is 40 km per second. So, the bus is moving according to a particular direction and also a particular magnitude. Okay, so can you give examples for vector quantity? Force, displacement, then velocity, etc. Example, force, then displacement, then velocity, okay, these are the examples for vector quantities. Okay, scalar quantity means it have only magnitude and no direction. And examples for scalar quantity is mass, time, temperature, etc. Then what do you mean by vector quantity? Vector quantity have both magnitude and direction. Okay. Then examples for vector quantity are force, displacement, velocity, etc. Okay. So we can say scalar quantity have only magnitude and vector quantity have both magnitude and direction. I think all of you got it. Okay, in earlier classes you have studied about what is distance, what is displacement, what is velocity, speed, etc. We can just recollect about it. Okay. First one is distance. What do you mean by distance? Distance is the length of the path travelled by an object. Okay, what do you mean by distance? Distance is the length of the path that is travelled by an object. The unit of distance is meter. Okay, what is the unit of distance? The unit of distance is meter and it is a scalar quantity. Distance is a scalar quantity. Okay, distance is the length of the path travelled by an object. The unit of distance is what? The unit of distance is meter and it is represented as small m. Okay, and the distance is a scalar quantity. Okay, I think all of you got it. What is distance? Okay, next we move to another term, that is speed. What do you mean by speed? We can simply say speed is the distance travelled in unit time. Okay, once more I will say what is speed? Speed is the distance travelled in unit time. Okay, so we can write speed equal to distance by time. What's the unit of distance? What's the unit of distance? That is meter. Okay. Then what's the unit of time? That is second. So we can write the unit of speed is meter per second. Okay. The unit of speed is meter per second. Okay. Next we move to another term, that is displacement. Displacement. What do you mean by displacement? Here you can see 2 points, that is A and B. Okay, so from A to B I am just drawing a straight line. Okay. From A to B, I am just drawing a straight line. Okay. So, A is considered as the starting point, or we can call it as A is the initial position and B is the final position, that is ending point. Okay. So, from A to B, I just drawn a straight line. Okay. From A to B, I just drawn a straight line. Here A is the initial position and B is the final position. Okay, then we can say displacement is the straight line distance. Displacement is the straight line distance from initial position to final position. Okay, displacement is the straight line distance from initial position to final position. Okay, in this displacement have both magnitude and direction. Okay, the displacement have both magnitude and direction. So it is a vector quantity. Okay, displacement is a vector quantity and the unit of displacement is meter and it is represented as small m. Okay, next we move to the another term, that is velocity. What do you mean by velocity? Velocity is the rate of change of displacement. Okay, what is this? What is velocity? Once more I will say, velocity is the rate of change of displacement. So we can write velocity. We can represent velocity by v. Okay, velocity is the rate of change of displacement. We can write velocity equal to displacement by time. Displacement by time. Okay, what's the unit of displacement? The unit of displacement is meter. And what's the unit of time? That is second. Okay, so we can write, so we can say the unit of velocity is meter per second. Okay. So, velocity we can represent by v. Okay, velocity is the rate of change of displacement. So, we can write velocity equal to displacement by time. Here the unit of displacement is meter and the unit of time is second. So, we can write velocity equal to, and the unit of velocity is meter per second. Okay, I think all of you got it. So, we can say velocity is a vector quantity. Why? Because it have both direction and magnitude. Okay. So, next we move to another term, that is acceleration. Here, acceleration that can be represented by using small a. Here, acceleration that can be represented by using small a. Okay, then acceleration is the rate of change of velocity. Acceleration is the rate of change of velocity. When velocity increases, acceleration of the body also increases. Okay, so we can write acceleration equal to a. So, a equal to change in velocity by time. Change in velocity by time. You already know what is the unit of velocity, that is meter per second. Then what's the unit of time? That is second. Okay, so we can write the unit of velocity is meter per second square. The unit of acceleration is, the unit of acceleration is meter per second square. Okay. Acceleration is the rate of change of velocity. Here we can represent acceleration by using the symbol small a. Okay, then a equal to change in velocity by time. Here velocity, the unit of velocity is meter per second and the unit of time is second. Okay, so we can write as meter per second square. Okay, I think all of you got it. Okay, in 8th standard you have studied about the equation of acceleration, that is a equal to v minus u by t. Okay, here u is the initial velocity. U is the initial velocity. And v is the final velocity. Okay, u is the starting velocity or initial velocity and v is the ending velocity or final velocity. Final velocity. Okay, I think all of you got it. Suppose you are traveling from AREEKODE to Kondoti. Here, AREEKODE is considered as the initial velocity or starting velocity. Okay, and Kondoti is considered as the final velocity, that is the ending velocity or ending point of a body. Okay, so we know acceleration equal to V minus U by T. Okay, A equal to V minus U by T. Okay, so we can find out from the equation, from this equation we can find out the equation for final velocity, that is V. Okay, we can find out the equation for final velocity, that is V, from this equation. Okay, so by cross multiplying this we get AT equal to V minus U. Okay, we want to find the final velocity. So I am taking V as outside. So we will get U plus AT. Okay, we will get U, V equal to U plus AT. So this is the V equal to U plus AT is the first equation of motion. Okay, V equal to U plus AT is the first equation of motion. Okay, I think all of you got it. Okay, here you can see a box. It depicts the velocity of a freely falling stone at each second. Okay, once more I will say, here you can see a box. Here time is given and velocity is also given. At 0 second, the velocity is 0 meter per second. In 1 second, the velocity is 10 meter per second. Okay, in 2 seconds it is how much? 20 meter per second. In 3 seconds, the velocity is 30 meter per second. In 4 seconds, how much is the velocity? That is 40 meter per second. Okay, so from this box, we need to complete this table. Okay, so here time is given and velocity is also given. Okay, so at time 0 second, the velocity is 0 meter per second. Okay, at 1 second, how much is the velocity? That is 10. Okay, 10 meter per second. Then in 2 seconds, how much is the velocity? That is 20 meter per second. Then 3 seconds, how much is the velocity? That is 30 meter per second. Then 4 seconds, how much is the velocity? That is 40 meter per second. Okay, I think all of you got it. How I completed the table? By using this box. Okay. From this, can we find out the acceleration of the stone in 4 seconds? From this data, can we find out the acceleration of the stone in 4 seconds? How can we find out? What is the equation for finding acceleration? What's the equation for finding acceleration? The equation for finding acceleration is A equal to V minus U by T. Okay. The equation for finding acceleration is A equal to V minus U by, we all know, that is U is equal to 0. Okay. Then V is equal to how much? That is 4. Okay, and the time given is also 4. We can easily understand from that box. Okay, time is also in 4 seconds. Okay, so we can write A is equal to, that is V. V is how much? That is 4 meter per second. Okay, A is equal to 4. Then A is equal to V minus U by T. Here V is equal to 4 meter per second. Okay. Then V is 4 and U is how much? That is 0. Then how much is the time taken the stone to reach? That is T is equal to 4. So we can write how much? That is 1 meter per second square. Okay, I think all of you got it. From the box, we can easily get the values of V and U and also T. Okay, here we find out the acceleration of the stone in 4 seconds. Okay, so I think all of you got it. Next we move to the topic graph. What is graph? I think graph is a familiar topic up to you. What is graph? Graph is a two-dimensional diagram. Yes, it is. Graph is a two-dimensional diagram. It can be depicted by connecting two values. A graph has two axes. Okay, which are they? Which are the two axes? That is x-axis and y-axis. Okay. This is the horizontal line, that is x-axis. Okay, here I am writing x dash. And this is the vertical axis. Okay, here I am writing y and here I am writing y dash. Okay, you got it? So, here the two lines meeting at a point, that is O. We can call it as origin. Okay, the axis towards right from the origin as positive. That is, the axis towards right from the origin as positive. That is, OX is positive and OY is also positive. Okay. Here OX is positive and OY is also positive. Then the axis towards left from the origin is considered as negative axis. Okay, here OX dash is negative and OY dash is also negative. Okay. I think all of you got it. Okay. Here OX dash, OY dash are negative and OX and OY are positive. Okay. In your textbook, you can see the graph related to world population and performance of a cricket team. From these two graphs, you can easily find out the year-wise increasing population and also runs scored by the team member in each over, and also you can easily find out which is the best over. Okay. Then what's the use of a graph? There are so many purposes we are using graphs. Then what are they, or which are they? Relation between quantities can be depicted. Okay, the first one is relation between quantities can be depicted. Then next point, equation connecting them can be formulated. Okay, equations connecting them can be formulated. Then what's the next use? Obtaining information from a graph is more simple than from a mathematical calculation. Isn't it? Obtaining information from a graph is more simple than from a mathematical calculation. That is, obtaining information from a graph is simple. Graph is symbol. Okay, these are the uses of graphs. The first one is relation between quantities can be depicted. Then the second one is equation connecting them can be formulated. And the third one is obtaining information from a graph is simple. Then from where? Then from what? Mathematical calculation. Okay, I think all of you got it. So, I am going to wind up today's class. Then, from today's class, what you have learned? What is distance? What is displacement? What is acceleration? What is velocity? What is speed? Etc. Okay. Then, we studied about graph and what is the use of graph also. Okay. I think all of you got it. Okay. Thank you.